How's it going, everyone? Andrew Robinson here, back at it with another Max MSP tutorial, and in this video we're going to be doing something a little different than what we would normally do. I was recently gifted a Launchpad Push Ableton MIDI controller device-esque thing, and I just want to see how well this works in Max and figure it out live on camera and turn it into a good learning session for you guys as well. So if you are interested in how to build a MIDI instrument in Max MSP, this is the video for you. So let's just jump right into it, shall we? First things first, any MIDI device you have, if it is an external MIDI controller and you want it to work in Max, the object you need to use is midiin, and that's midiin, midiin, and you see it says outputs raw MIDI data. If you create a midiin object, lock your patch, which you can do by clicking this lock icon or command clicking anywhere in the blank space of the patch. And then once your patch is locked, if you double click on that midiin object, you're going to see a drop down list of options. It says Launchpad X, LPX.out, there's a MIDI out, and then to Max 1 to Max 2. These are the external MIDI hardware that you can read into Max MSP. I would, if you are using your own external MIDI hardware device, it will pop up in this drop down list, but as far as which one's the right one, sometimes it's just a little bit of guess and check work. Since I am not outputting to a DAW, I want MIDI, I'm going to assume I want the Launchpad X MIDI out. And if that works, once we unlock our patch, we should be able to start reading MIDI data in right away. And if I just attach this into the right inlet of a message box so we can see its output displayed in the message, and I hit something on my Launchpad, yeah, we're getting numbers. That means MIDI is being read in. But what does this MIDI data mean? Well, it said it was raw MIDI data, so we actually have to do some further parsing, if you will, on this data to actually get it to be the correct MIDI events that we want in order to control our patch however we want. And the best object to do that, you're going to use this every time with midiin, it's midiparse. And that's right, it interprets raw MIDI data, which is what this outputs. So it's exactly what we need. We're just going to patch that into the inlet of midiparse, and you see it has all these different outlets. Note on off, which is a list for pitch and velocity. It has poly key pressure, control change list, aftertouch, pitch bend, anything you need, anything MIDI, any kind of MIDI data, this is going to parse out for you. And if you don't know exactly what you're looking for, which is going to generally be the case when you're building a new instrument with MIDI hardware, you're just going to need to do a lot of guess and check work. So my recommendation, once you get to this step, is to create a bunch of message boxes for every single outlet of our midiparse object. And if we just patch each one of these into that right inlet of the message box, we're going to see its output displayed in each of these. And then as we start to touch buttons on our MIDI controller, we'll see what data pops up, what is doing what, and we'll start to make some connections between what the data is showing and how we want to use that. So now that everything's connected, I'm going to just hit another button on my controller, and you'll see we're getting some information from different outlets. This first one, as we saw, was the note on and off, which is a list of pitch and velocity, and this second one is poly key pressure, which is also a list value. And you can see actually these numbers are the same, so it's giving us that note on and off, that pitch value according to the button that I am currently pressing. But what's nice is because this also outputs poly key pressure, it's giving us that variation. As I start to press harder or softer, this velocity value changes, whereas this one, it's just on, off, and at the velocity that I tap, but it is just that. So here would be some creative choice that you would have to make. Do you want just the note on and off and that stable velocity, or do you want to have that velocity value constantly changing and modifying different aspects of this project? That is totally up to you. I think because this offers poly pressure, and I actually don't see that very often with a lot of the MIDI controllers I've used in the past, I'm going to use that. I might change my mind. Again, I am building this live in front of you guys, so I don't know where I'm going with this. I have a general idea in mind, but we're going to just see how it turns out in the end. But I do want to separate the note on and the velocity message in order to do my initial idea that I want to try out. So I'm going to use an unpack object, and we're just going to say II because we're dealing with integer values, and we're going to unpack our note value and our velocity value so they are separate values. And we are then going to attach this into a make note object, which I'm going to default with these values. This is our velocity, so that's going to go in there, and this is our pitch, so that one's going to go in there. And then the make note object just reformats the data to be a MIDI message, and then we just pass that to the note out object. And we also patch this into the velocity note out inlet, and yeah, now you'll see that as I'm pressing these, we are getting MIDI notes and sounds. And you hear it's doing that like trill effect. I think the reason for this being is because every time this velocity changes from this poly key pressure object, it is also re-outputting the pitch value along with that, because it's always outputting it as a list. And so we're constantly saying play this pitch at this new velocity, which is creating that trill. If we were to use this first outlet of midiparse, which is just that stable, you don't have that anymore. And again, whichever you want is your creative choice. There's no wrong answers when it comes to that. It's what you like and what you think is cool and sounds good and is what you want to do for your patch. I'm going to go back to this because even though that trill maybe might not be the technically correct option, I think it sounds interesting and I like that effect, and I'm going to use that creatively in this instrument that we're building. Now the next step after creating our note out of what I want to do is change the sound of the MIDI synth, which we can actually do using this super cool object called pgmout. And this, I believe, stands for MIDI program changes. So with the pgmout, we can change the sound of the MIDI synth, and there's, I believe, 128 different MIDI synths that we can choose from. So I'm just going to create a random 128, and I'm going to patch that into here. And every time this now sends out a random value, which I will demonstrate first with this bang, I'm going to lock the patch, click this button, that bang went out, it passed a random value of 108. And that's our new MIDI synth sound. Click it again. New MIDI synth sound. So already we're getting really cool sounds with this really cool trill effect. I already really like where this is going. Now what I think I want to do is I want to trigger a new MIDI synth sound randomly every time I play a note. And there's probably a few different ways to do this. I think what would make the most sense is if I copy this unpack object over again, and we take this leftmost outlet of the midiparse object, which is that stable output of the MIDI event, and I'm gonna say, if we want it to change every time I play a new note, what would make the most sense is presetting it so that after I let go of a note, it will change for the next note. And in order to do that, if that makes the most sense, that's what I'm going to go with. We're going to say less than or equal to 0, which will be the velocity value. So if our velocity is less than or equal to 0, meaning nothing is being played, we are going to then have that turn into a bang using the cell1 object, because this will output a 1 when it is less than or equal to 0, meaning 1 meaning true, and we'll turn that 1 that it passes into a bang, which will hit the random. And so every time our velocity is now equal to 0, this will randomly change to a new number. And I'm going to just check real quick by patching that into a message box. And that is working. Every time I play a new note, we have a new sound. You'll see though, it sort of sometimes changes really quickly and rapidly. We can easily fix that by adding a change object into our data flow. If we add that right here after the less than or equal to object, What it's going to do is change will filter out repetitions of numbers. So what was happening was maybe like 3 or 4 ones would pass through this patch chord to the cell and send out 3 or 4 bangs and 3 or 4 random numbers, because it was true for those moments, enough to send out 3 or 4. But by filtering out the repetition of all those ones, only one is going to pass until this number changes, which it will once it's no longer true, and meaning a note is being played. So 1 1 will pass through, all the other ones will get filtered out, and then whenever I let go, this value will, or whenever I play a note, this value will be a 0, because it is now greater than 0, which will reset the change and get it ready to look for the next one coming through, which will be when I let go of the note. And we should see that work now. Yeah. And that is working exactly as intended. We are only getting 1 note change per 1 note being played now. That's pretty cool. So let's just play around and just see how this sounds as it is. Okay, well, some initial notes is I feel like the note length is way too short. I want to be able to create a cacophony of crazy sounds. So rather than being 500, I'm gonna make this something ridiculous. Let's, I don't know, let's do 5,000. So it'll last for 5 whole seconds before the note fades out. That's better. I'm gonna make it even more ridiculous. Let's go up to a full minute. Let's do 60,000. That is so much better already. That has like that long tail and kind of gives it some like polyphony vibes. And I kind of now have this idea. It would be nice because with the longer tail, it really gives it that space that I'm looking for. But it would be nice if I like happen to like do some crazy chord of sounds, have that hold out while I start to play other notes. So that way I kind of have like, you know, I can like build myself a bass that I can then play on. And to create some MIDI sustain based on chords would mean I would have to track how many notes I'm playing. And if I'm playing more than a certain number of notes, I would have to remove the note off message for that chord, which I think is actually possible to, it's definitely possible to do, but I think it's possible to do pretty easily because there is this strip note object which filters out note off messages. I believe if I just patch this here in between our make note object and our note out and I play something, it should just hold this note now. It did, in fact, hold that note. It should hold the note for the whole full minute, but maybe that also depends on the synth being used. This, I'm not sure. Yeah, okay, I think it's working now. I'm gonna mute my computer for 2 seconds just so you can hear me talk and not hear that note. But yeah, okay, I think that's working. So now, okay, so with that, I'm able to filter out the note off messages, which means I can hold the note out if I play a chord, but I need it to know if I'm playing a chord, which depends on being able to track how many notes I'm playing at once. And I think I can actually do that with this neat trick I learned pretty recently, actually. There's this object called bag, and it stores a collection of numbers. And if we look at the help file real quick, it's kind of interesting how this object works. You store numbers in bag by sending it a list of a value of where, I believe, in the bag you want it to be stored, and then the value to store. So it's these pairs of numbers. And actually, I'm not even sure, to be honest, if the second number has to do with position. But what's neat about how bag works is you can then remove the numbers from that collection system by sending it the same value and a 0. So we can actually store these numbers, the note I'm playing, plus the velocity, and then easily remove it as well, because the note off message will take it out of the bag. Yeah. And I think to do that, I'm going to use the trigger object, because we need to pass the list into the bag, and then we need to send it a bang to get it to output. And if I patch that into a message box, we're only seeing one number, but it should be outputting a whole list. So let's double check with print instead of message. Yeah. No. I think that's sort of working. It's kind of hard to tell. I think because I'm taking the things out as soon as I play it. So I'm going to click one note, then I'm going to click two notes. Yes, and we got both note output again. So it is actually working as intended. As long as I'm holding down these notes, it's going to output the MIDI value of that note. And if I let go, it passes it with a 0 into the bag, which then removes that note from the bag. Thus, it no longer gets output, which is perfect. That is exactly what I want. It's kind of interesting. It does output them iteratively, so immediately one after another, which is why we're only seeing one number in the message box, but we're seeing everything pop up in the Max console with the print object. So that, if you get nothing else from this video, that alone is a really useful technique to debug and double check your work, because sometimes the message box doesn't display everything that's getting output. It's only going to display the last thing it received. So if you are expecting more values and you're only seeing one value, use a print object and see if everything is getting print to the console, and that'll help you figure out where your patch might be going awry. But okay, cool. So we are getting everything, and if it's printing iteratively, that's actually not an issue for us either, because we can use this object called thresh, which will combine numbers and symbols and lists when received close together. So if these are all outputting iteratively, immediately one after another, they're all going to be received by this thresh within a very close proximity of time. And I believe with thresh, you can even define it. Yeah, there's two arguments for it, the threshold and the threshold time. I think the threshold is how many numbers it needs to start creating a list. I should probably double check that. Okay, it's really just one argument, which is the defined threshold time. So every number that this thresh receives within 50 milliseconds will be combined together into a list. And we can check this with the message box, because rather than getting one integer output now, we should get all of them as a list. And that is, yeah, that is working, because there they all are. And if I let go, they should be removed. Yes. We are getting duplicates though, so we need to thin those out. That's also easy to do. There's a ZL thin object, which removes duplicates from a list. So there we go. Now I'm only holding two notes and we see only two. I just pressed another, so third, fourth. I'm now holding 5 buttons down and we see 5 notes are being played. And as I start to let go of these notes, we see they are being removed from the list, with the exception of the last number. That will stay even though I'm no longer holding it, but that's okay. We don't really need to worry about that, because all we want to do is get a count of how many numbers are in this list, which we can do with another ZL object, that is ZL for length. It gets a list length. We'll patch that into there, and we'll see that this will return an integer value depending on how many notes are being held. And we'll say, yeah, if it's equal to 4 or more notes, that's how we'll know that a chord is being played. And we're gonna need some gates now. So I'll say gate 2. We'll need 2 gates. We're going to pass our make note object into the gate. One for the pitch and one for the velocity. Let's see. Then we'll say we want it to come out of the leftmost inlet when it is less than 4 notes. And this will be a 0 or a 1 if true or false. But this gate needs a 1 or a 2 to control which outlet it's going to. So that's really easy. We can make these work together simply by adding 1 to the output of our true greater than or equal to object. So now if it is less than 4, we're adding 1 to that 0, so we'll get a 1 out of this output. And if it is equal to or greater than 4, we'll get a 2 out of this output now, because it's 1 plus 1. And we'll patch that into the leftmost inlet of the gate object. And this should control the gates correctly now. So when it's less, it'll come out of this outlet, and when it's more, it'll come out of this outlet, which will run into the strip note object to create that potential sustain. And because I left that plugged in and was hitting buttons, there's already some stuff playing. So let's give it a sec. Okay, and now that that has died out, let's see if this works. Yep, I played a chord, I let go. It's holding that chord out. But I can still hit new buttons and play new notes, and it doesn't sustain those. I played another chord and it's holding those. Okay, so that's working perfectly. That is pretty amazing. I could play with this for a while, and I think I'm going to. I think I'm going to end the tutorial video right there, pretty much. The only thing in terms of knowledge that I think you need to know that I'm going to pass on before this video officially ends is just we're going to take a real quick look at the rest of these outlets of the MIDI parse object, because you see there's a number over here, and there's been this message box which has been saying stuff the whole time I've been messing around, and we didn't even look at that. So let's just talk about that stuff real quick. These other ones are blank, so nothing came out of the control change list value, nothing came out of the program change outlet, there was no aftertouch. But this one, oh, this is pitch bend. Nothing came out of there. This is the one that passed that one integer we see, and this is the MIDI channel. So I guess that's just telling us that every note that I'm playing is on that first MIDI channel. That checks out. The pgmout also works on MIDI channels. You'll see that in the help file, there's this option to set which MIDI channel you're talking to. So you have a lot of control over what you're doing that way as well, which is super helpful. And then this outlet, this is actually the most important one. This will output MIDI event messages, which is basically just the correct formatting for anything that the MIDI controller is doing. You'll see that the number here, it's 67, and then it's like kind of jittering around. That matches this value. And what this is saying is MIDI event 160 has just occurred, which must be note on. And this is the note on value and the velocity that comes with that. If I let go, you'll see it changed to MIDI event 144. So MIDI event 144 is the note off MIDI event for this controller. And you now see the correct list that goes with that. So if I was doing other things, and you may notice it more on your MIDI controllers than this, because I only actually have these buttons to play with. I'm realizing none of these other extra stuff is being read by Max, which means it's not actually, the device itself is not outputting it as MIDI. But you might see a lot of different stuff, and it's super helpful to build a lot of your Max code that you're doing through these MIDI event messages as well, because this value, this 144, specifically corresponds to what occurred with that action and your MIDI controller. So you know that 144 will always be this action. So it's really useful to use that if you want super specific things to control other things. I don't know, Max lets you map anything to anything. You can totally run wild with this idea. If you're trying to like perform and also control your own lights, you could have like the note off here, turn the lights off, or turn them on if it's a note on, whatever you want to do. That's what I'm saying. That's the power of using MIDI in Max. It's super easy, and the more buttons and knobs you have to play with, the more stuff you can map those controllers to control. And hopefully, you guys learned something about how to set this up and do this kind of stuff on your own through watching me just try to also do it with some new MIDI controller that I recently received. So if you guys did learn something, please remember to like and subscribe, because that is how I know best that you guys learned something from this video. If there are any questions or comments, please feel free to leave that in the comment section down below. I will answer them when I can. And on that, I will see you guys in the next video. Thanks so much for watching. Goodbye.